I think the previous presentation by Dr. Chang was also very, very relevant. It's about becoming visible in this autonomous future that we're in at the moment. And so I think we're moving one step beyond the visibility importance itself into being able to quantify. Because if you can quantify visibility, you can start comparing visibility. And especially in the application of the mobility sector, what we're working with is complex shapes, cars, bikes, scooters, and they have complex shapes and different orientations in the traffic environment. So how can we move on there? So being seen by these semi-autonomous vehicles, will we be seen? Will our loved ones be seen? So imagine everyday low-light situation, every night when you go home or when you leave home for work, and then arriving home safely. So to have a dinner with your family, taking your kids to soccer, have a good time with your friends. Imagine the same situation and not arriving home safely. Empty places at the table, all because of accidents happening along the way. Of course, this is not only due to visibility, but anything that we can do to improve visibility or improve detectability is something we should consider. So imagine the same everyday low-light situation. Which vehicle would you choose for your loved ones to go home? Which one? The more visible one. Why? Why? So isn't it important to start thinking about visibility and quantifying and comparing visibility? So that's why we developed a three-dimensional color visibility label. So if you're buying a scooter for your daughter, for your son, or helping fund it, which one would you choose? The one with a higher visibility? And how do we know it's a higher visibility? It's something we can measure now. So we believe in the future that every mobility color will have a visibility label so that the consumer can make an informed choice on a safety aspect. So this is the visibility label that we developed. There are, basically we have 5 parameters. 2 of them are sensor visibility parameters, and 3 of them are human visibility. So how visible is your color on a 3-dimensional object for camera visibility, like a Tesla, and how visible is your color on for a LiDAR system on a 3-dimensional surface. So we'll go into more detail later. Very short about Inconvent. We're a Dutch-based company. We developed a new class of effect pigments. We call them crystal glass pigments under the commercial name Reolite. And we developed 2 new color concepts to be able to describe what it does to color, because it changes color or it adds a new color dimension. And it's eyeball visibility and twin flop effect. We also developed this visibility label to be able to quantify three-dimensional visibility of colors. We also won a CMF award in Shenzhen last year, also signifying the color effect, or the newness of the color dimension that it does when you add Reolite to existing colors. If you look at the color visibility, basically it's a new value chain, like Dr. Chang was referring to. What is visibility? How is visibility? How can we measure this? So if we look at Inconvent as the company, we have the paint companies that paint or create paints, but also then sell it to OEMs and brands, and finally sell it to the consumers. So we've been working on educating or talking with formulators about crystal glass pigments, about visibility, educating visibility, and now that we can measure it. So all these paint companies are working with crystal glass pigments or have been testing it. 80% are approving crystal glass pigments for automotive coatings. 2 have already approved it and are developing new coatings with about 13 plus brands to increase its visibility. We're also talking to brands or educating brands on the visibility of their colors, their color portfolio, all of them all over the world. So also so also in the Far East, Xpeng, Zeekr, Hongqi, Deepal, but also in India, all of them are becoming aware of color visibility of their colors. So what we did is we developed the visibility label so that brands and formulators can talk together about how visible they are. Some OEMs are more interested in LiDAR visibility, some are more interested in camera visibility, and some in human visibility. What we also did was we developed a visualization tool so that we can explain what is it actually that we're doing. So in this last step, once the value chain is ready, so going through the formulators, OEMs, and awareness of visibility, we can also start educating the consumer. The consumer can make an informed choice. So a short movie on what is it, what happens to your color when you add real light. So what we did is we took an existing color, Volvo Bursting Blue. So this is a digital representation. 2 blue cars, one of them has real light added to the blue color. And during the day, the color stays the same. So this is a very important aspect. Color designers, they really like their original car colors and they want to stay as close as possible, but they still want to be visible. So during the day, the colors look very similar. But at nighttime, only under the direct lighting system of headlights, for example, when you move into the direction of the headlights, you can see that one color becomes more visible. So if you're moving at higher speeds, we were also, Dr. Chang was also talking about that, if you can better detect an object or another vehicle and classify what it is, higher classification, the reliability, the computer can help you make better decisions. So the fine lines and the higher angled surfaces. We always end these movies behind the steering wheel because that's where you need this increased visibility of the objects. So then the second thing is the 3D color visibility label. So what we have here are five parameters, 2 for sensors, for camera, LiDAR, and 3 for human visibility. A is the most visible color and E is the least visible. So where are you on the range of from glossy white to glossy black, if you want to compare that. The model for this label was published in the SAE International Journal for Connected Automated Vehicles last year. So also signifying, after a double-blind peer review by 4 industry experts, that it was a very relevant and actual challenge that needed to be solved. We even won an award for this new model and the implementation of this model. And now we can also measure this real time. So we used to do that in Holland, but now also we have a small booth and we have this prototype on the booth and you can have your color stylings measured. Companies, automotive companies and paint companies were sending us panels, new color stylings from all over the world to measure the visibility label, but now they can start doing it themselves. So this is more the technical side. So what is important in color visibility? So we look at an object. Automotive colors are designed on flat stylings. So we have a rotating stage, we have a LiDAR system, we have a camera system, a light source, a computer of course, and we can print this label after it's been measured, and also a report is generated. So with this machine, formulators can measure all their colors, their whole color portfolio, the black ones, the white ones, but also all the other colors in between. The gray ones we heard, black, white, and gray is 80%, but how visible is your gray? How visible is your black? Or how invisible is your black? So now you can measure your whole color portfolio and start thinking about it and what you want to do with it. Use it as to integrate it into your marketing strategy on safety. What's very interesting is that Axalta, or the industry, is already acknowledging visibility of colors to be important. So this was from their trend portfolio from 2025 already, be visible. So be visible, so your colors need to be visible, so you are more visible. And very interesting line here, innovative colors boost visibility in low light conditions, contributing to a safer and traffic environment for all vehicles. So this awareness is becoming more and more clear. And this was from already 4 or 5 years ago from Heubach, Clariant, now Sudarshan. They already, 4.5 years ago, they already added in their color descriptions near reflectance, near infrared reflectance. How visible is your color for LiDAR systems? So how we look at this is we're looking at as a fully integrated autonomous future. This future where time and a place where semi-autonomous, they're already here, different levels, 1, 2, 3, 4 going towards 5, fully autonomous, but still a lot of human-controlled vehicles all have to coexist and move together safely. This is the future that we're in now already, and we're going towards more and more. So what is the most important thing in this future? That we can all see each other. So, but maybe your color is already visible for humans. One color is more visible than the others. Well, let's measure it, how visible it is, to be able to compare the visibility. Maybe your color is already visible for semi-autonomous driving, or not, because this car was operating partial driving automation, but did not see this car. It was parked on the highway. So not only ADAS itself, or the self-driving systems themselves, do not solve all the problems, you also need sensor-friendly and sensor-visible colors. How visible are my colors for these sensors? So let's measure it. If you look at the fully autonomous driving, we were in China end of last year, and we saw the self-driving cars, and it's pretty scary. You would rather just drive a little bit around it. But so let's, will they see me? Will they see your loved ones? So let's measure the visibility for these sensors that are being used. So the colors of the future, very important. Everywhere where we go, the colors need to be beautiful, because that's the whole idea behind colors. That's how the whole positioning of brands are being used. But now they also need to be visible. Colors need to be visible. They need to be sensor friendly, going towards the future, and so therefore they need to be measurable. How important is the car color on crash risk? Is there a relationship? There were 850,000 crashes that were analyzed in Australia, and these were the results. So during dusk and dawn, a black car has a 47% higher crash risk than a white car. Even during daylight hours, a black car had a 12% higher crash risk than a white car. But what they looked at blue or these different colors, they didn't look only at the blue. There was light blue, dark blue, sparkly blue, metallic blue. So even without taking that into account, statistical significance was attained. Of course, the color itself is never the only reason that accident happens, but it was a statistical significant result. So how can we measure the visibility on these two colors, for example? And especially because the automotive industry uses flat panels to make new colors, or to design new colors. How can we determine the visibility on a three-dimensional object using flat panels? Well, to do that, what we did is we took two different colors on two car shapes, and we made a flat panel of both of them. If you look at them on a nearly perpendicular, so only 6 degrees just off the perpendicular, you see that they're both very similar in lightness, in contrast with the background. So you're looking at this part, and that makes, and there they're equally visible. If you move a little bit along the curvature, you already see that this color goes darker quicker than this one. If you move even further, you can see that this color sort of loses its contrast with its background. So what this means is that every color has an angular dependency for human and camera visibility. If you use these same two panels for these two colors and look at it with a LiDAR system, for example, under the same angles, so this is 6 degrees, you can see that the reflectance is 90. So again, if you're looking at the perpendicular part with the LiDAR system, perpendicular to the color, then it's the same visibility. But again, moving along the curvature of the shape of the car, you already see a drop-off from 47 to less than half, to 21 for this color. And if you move even further, you see a drop-off from 23 to less than a quarter, to 4. So what does this mean? That every color has an angular dependency of LiDAR visibility, every color. So if we take a complex shape, a car shape, it's very difficult because there's new models and new car types coming out every month nowadays. So we need a sort of a comparative representative shape. So if we look at a semisphere, you could say that it is relatively, it could be representative. There's one part that's very specular, very reflective, and the rest is all curved away from you. But if you look on the top of a semisphere, what does the driver see? What does the camera system or the LiDAR system see? It sees a circle. Now if we would divide this circle into 5 rings, each ring would have a different average angle. We can calculate those angles by extending the middle of the ring to the surface, and then we get 5 different angles. So what we do is we measure a single color styling under these 5 angles that are determined here. But then you only have a measurement on one of these black dots. So in the middle is the highest reflectance, but it's the smallest area, it's only 4%. The outer ring is the lowest reflection, but it's the highest or the largest area. So each ring has a different contribution to overall visibility. So this is the model that we use for the visibility label to determine the 3 human vision parameters, the computer vision parameter, and the LiDAR parameter. So that's what it results in, and how you can measure and then compare the 3-dimensional visibility of colors. So we have the prototype 1 now also with us, where we measure stylings for both OEMs, brands, but also for paint companies in the color styling development. And we're doing this all over the world because this realization is coming more and more on, we have to say something about sensor visibility. I was in Japan at a big paint company last year, and they said that an OEM customer had already asked them for sensor visible colors. I said, well, that's great, that's amazing. Did they give you any specifications? No, because there are no specifications yet. With this visibility label model, we can start measuring and comparing, and then as a second step, writing specifications. So we're working on prototype 2, already improving the process. It's all based on this publication in the SAE. And then we're working for a pilot series. This pilot series should be ready at the end of Q2 this year still, and will be offered to selected OEMs and formulators so they can all start measuring their whole color portfolio and start thinking about how to integrate visibility into their safety value proposition of the brand. And to have a commercial version by the end of this year. It's coming smaller and smaller and smaller. The idea is to have this towards a handheld measurement machine, so you can also use it in quality control. So, and then after that, we can also start initiating consumer marketing, so that the consumer can have this choice, can be informed better on the visibility of colors and safety. So that was more about the visibility model. So every color can be measured in visibility. What we did here is we took an existing refinish color, bursting blue, and we added different concentrations of these crystal glass pigments, 0, 1, 3, 6, and 10%. Post-addition, just mix in on weight basis and normal application. Under a 45-degree angle, they look very, very similar in color effect and color hue. But in the direction that you need it, you can see, so when the light source is aligned with the camera angle, you can see a very big difference in the original color, 0, 1, 3, 6, and 10%. So even adding 1%, you can significantly increase point of view visibility for LiDAR systems, for camera systems, and for humans. So we also measure the visibility label for these colors. So for human visibility, computer vision, LiDAR visibility, full object visibility, how much of the shape do you see, only specular or also the high angled surfaces, and how visible is your color after sunset. And the one thing that jumps out here, of course, is the increase of full object visibility. If you say that the original is 100%, how much better is the 10% addition? So it's a 3,200% improvement on visibility for this color, for seeing more of the complete shape of the car or bike in that color. So this is a real-world example. This is my Mercedes in Holland. We, under ambient light conditions, it looks pretty similar, but we did 3 different stylings on this. And that's what you can see now. So the darker lines are the original color, Bentley tungsten. In the middle we added a little bit of rhyolite, and on the outer sides we added a lot more for demonstration purposes. But it also works in the sun. So if the sun is behind you, you get this whole new kind of glow of this new color effect pigment. We also dubbed this addictive beauty, because one of our customers had painted his car in a special BMW Havana, and every time the sun was out, he went outside to have a look at his beautiful color. So the same color, so how does this really improve this visibility? Because during the day, you don't really see a big difference in ambient conditions, but at nighttime, just under normal headlights, you can already see that the color of the body becomes much more visible under higher angles, even very thin lines. And here the skirting is original color. And here these 2 lines that you saw on the previous page is also the original color. So you see much more of the shape. And if you increase to high beam, you can see much more of the whole car shape. So really increase visibility of the complete object, so the higher angle surfaces, making detection and classification much easier. So what are we doing? We're basically decreasing the risk of not arriving home safely. How we're doing this? By three things: creating awareness of color visibility. Which one would you choose for your loved ones to go home? The obvious choice. Can we now measure this difference in visibility? Yes, we can. Can formulators and OEMs now measure it themselves? Yes, they can with the VLab tabletop. And can we then, after we have measured them all, can we improve this visibility? Yes, you can. You can use Dr. Chang's different pigments, the Mobilite pigments, or you can use Reolite, or you can combine use of these new pigments that are being developed. So these two bikes, they look similar during the day. They have both similar blue color, but at nighttime there's a huge difference in visibility. During the day they look very similar, but one of them has Reolite inside, crystal glass pigments, and becomes much more visible under direct headlight. These two look similar in grayness during the day, ambient conditions, but at nighttime under a direct headlight become much more visible if you use Reolite crystal glass pigments. So this brings me towards the end of the presentation. So the colors of the future, because that's what we're talking about. Colors now are being developed for colors in 28 and 29. So that's what we're talking about. Sensor visibility, how visible are these colors? So if we look at the visibility label, basically it can touch the lives of more than 1 billion people on a daily basis, going to work, going to school, and arriving back home safely. Being aware of color visibility can have a big influence. Crystal glass pigments to create more sensor visible and sensor friendly colors of the future. And why is this important? Because we're going there and enabling a faster and a controlled transition to this fully integrated autonomous future. And by integrating sensor visible colors into the color styling portfolios of automotive OEMs and also the offering by formulators. So as a last slide, which one would you choose for your loved ones, your kids, and your partner to arrive home safely? Thank you.
Very interesting topic. Nice to have the succession of those presentations like that. Are these glass pigments or crystal glass pigments considered semi-circ stable? Are there any special considerations the OEMs need to have in their paint shops to
a lot of testing has been done, and also signifying that two automotive paint suppliers have already approved it for automotive coatings or paint and colors. A lot of testing has been done, rigorous testing, to make sure that it fulfills all the requirements.
Nice to know they're good to go. Are the federal regulation agencies considering adopting this scale that you guys have come up with?
Thank you for that question. Regulatory agencies, what they need is a visibility model and is a standard and usage, because then you can start gathering data and make it into statistical results. So we started with the model, we're starting with the machine now, and now we're integrating the machine, getting it into the industry to be used. So as a next step, in parallel we are working with ANCAP, or discussing with ANCAP new car assessment programs for integration of visibility of your car color into the description of your car.
Yeah, it's real interesting to see, 10 years ago and how the agencies have communicated, and it's sort of been a free-for-all when it comes to development and what the regulatory requirements will end up being.